Port, or shim, stress testing application performance on Intel SGX. We'd originally set out to test the performance of applications when ported to SGX. We took a benchmark suite and ported it to run on SGX, and to compare the performance, we used an existing interface layer to run an unmodified version of the same program on SGX. We'd assumed that direct porting would be faster, but the performance for both approaches was nearly the same. This surprised us, so we set out to investigate the types of workloads that would benefit from direct porting. Intel SGX stands for Software Guard Extensions. They're a set of CPU instructions that help run programs in hardware-protected areas of memory. These areas are called enclaves, and allow users to run their programs securely, even in the presence of other malicious software, including the OS and hypervisor. An SGX application has its own code and data, and the enclave. The enclave also contains its own code and data. A certain amount of memory is used for enclaves, which are stored in a protected area of memory called the enclave page cache, or EPC, which are about 90 megabytes in size, after accounting for metadata. A part of the SGX hardware is called the memory encryption engine, which encrypts and decrypts memory accesses between the EPC and on-chip caches. Other than the size, there are also some limitations on what can be done inside an enclave. The program needs to exit the enclave, make those calls outside, and then re-enter with the results. There are some overheads involved with running programs on SGX, entering and exiting the enclave, the encryption and decryption overhead due to the memory encryption engine, and EPC paging, which involves a significant overhead, and the general consensus is to avoid it at all costs. Given the restrictions on what can run inside an enclave and the size of the enclave, the programmer needs to think carefully about how to partition their code for SGX. Another approach is to use shimming, which involves a translation layer that provides an interface to allow whole modified binaries to run on SGX. The programmer doesn't need to think about how to split their code. This greatly simplifies and shortens the development process, but possibly worsens performance. Through our work, we found that programs may perform better if manually ported as opposed to run in a shim if the working set of data inside the enclave is smaller than the cache size, but the total working set of the application is larger than the cache size, the application has relatively few enclave transitions, and more time is spent working on the larger data set outside the enclave. For most other cases, it may be better to use shimming.